Good afternoon, students. We'll start with chapter 6 of unit 3. That is, chapter 6 is deadlocks. Now, deadlocks is basically a new topic for you all, and deadlock is a type of, we can say, a solution which has been, or a problem wherein there are actually reasons for a resource access. And when you talk about resource access, that is, I have one pen, that's an example. If I have one pen and to share that one pen between two people, I require a time duration. And if I try to access that same pen at that particular time, what the problem which I will have is deadlock. So when I have resource access and that resource access is to be taken at that particular time by two or more than two people at that same time, can occur with a problem called as deadlock. So there are various preventions which are being taken. What are the types, or what are the resources which are there for these deadlock occurrences, or what solutions can be taken out to solve these deadlock problems, are being given in this chapter. Now, deadlock, why it occurs, how it occurs, is what we'll see further. So, a major class of deadlocks involves resources to which some processes has granted exclusive access. So, deadlock involves with resources. So, whatever resources we are having for processing will have some problems or granted exclusive access. When they are exclusively accessed by somebody, there will be some problems, and that are termed under deadlock. These resources include, now what are those resources? When we talk about the operating system, that can be devices, that is all your input output devices. Data records, that is the tables and pages which are being processed over your operating system. Files, again your file types, your major file access, your folder access, and so forth. So these are the examples which we can say are the resources which are creating a problem which is called as deadlock, which is actually related to deadlock. We cannot call this as deadlock. So resource access by more than two or three people at a time can be termed as deadlock. So, to make a discussion of deadlocks as general as possible, we will refer to the objects granted as resources. So, the main term in this chapter is resources, and that resource access can be called as, can describe further as deadlock. So, a resource can be hardware device, that is a Blu-ray drive, or a piece of information, that is a record in a database. A computer normally have many different resources that a process can acquire. For some resources, several identical instances may be available, such as three Blu-ray drives. When several copies of resources are available, any one of them can be used to satisfy any request for the resource. In short, a resource is anything that must be acquired, used, and released over the course of time. So, what does this whole paragraph, the second paragraph, means? That is, a resource can be a hard drive, or it can be a piece of information. Now, that resource generally does not only mean your input and output device, it can be anything what you want, which is available to complete your task. And that can be, if it is one, there cannot be there should be a resource sharing. If it is more than one, if resources, like they have said here that Blu-ray drives are more than one, that is they are three, so they can, if there are several copies, you can share among them, like you can divide it among the resources, the actual process which is working for that resource. If not, what you can do is you have to wait, that is until and unless someone is done with their work, they cannot use that. So what is resource? A resource is something which you take it, that is you acquire it. Once you acquire it, you do your task, that is you use it. Once you use it, your work is done, you release it. That is the actual course of your resource over the period of time. Nothing else is done with the resource. So resource come in two types. So there are two types of resources: preemptible resource and non-preemptible resource. Please keep this in mind. resources are of two types, because further there are many jumbling things which will come. Please keep this in mind. Resources are of two types. These are not deadlocks. These are resources. I repeat, resources are of two types, preemptible and non-preemptible. So when I talk about preemptible resource, that is this one. When I talk about preemptible resource, this resource can be taken back from the process to which it was allocated with no ill effects. Means once my work is done, after that I can take back it from the resource by without owning it. That is, even if I do not have any rights over that resource, even if I take back, I will have no ill effects. That is, I do not have to face any conditions there. That is called as preemptible resource. Memory is an example of preemptible resource. Yes, memory is shared over all the systems, and for that memory you do not have to go and search something. Once a person's memory task is done, you can return back that memory to the actual process which requires memory. So memory sharing can be a good example of preemptible resource. You can take back it from anyone without any problems. So that is, they have given an example here, that is, consider a system with 1 GB of use memory, one printer, 2 GB, two 1 GB processes, and each want to print something. So this is one example which is being given that we'll discuss further. First we'll move on to what is actually resource. As I have described you, sequence of events required to use resource, that is, request the resource, that is, acquire it, use the resource, and release the resource. So these are the all things which my resource does. And what are the two types of resource? Preemptible and non-preemptible. To go slowly in this chapter, the reason to go slowly is because this topic is totally new, and once the concept is not clear, you will not understand further what topics are going on in this chapter only. So that is the reason I am going very slow. So resource acquisition, that is, if I acquire the resource, what are the types? So using a semaphore, that is, using a programming code, how do I acquire a resource? So basically, first one, that is, A1 is one resource and B1 is two resources. So as you can see, semaphores are the calculations of functions which are being set on those resources. So type definition in int semaphore. So semaphore is an integer variable. It's not your normal variable. Int means it will have numbers starting from 0 to any of that. So semaphore resource 1. So they have described resource 1. Void process a void. They have made a class called as process underscore a, and which has down resource 1, use resource 1, up resource 1. Down here means acquire it. Once you have made it in your account, what you can do? You can use that resource. Once you use that resource, after using that resource, up resource 1, that is, you release the resource. That is the use of only one resource. Second one is type definition int semaphore. Semaphore resource 1, semaphore resource 2. They have described two resources here. They have created a class void process underscore a void, that is void main. You cannot use it, you can use it further as well. Down both the resources, that is acquiring it, use both the resources, and up resource 2 and 1, that is whichever resource you are using. Once you have done, see, they have taken it vice versa because they want to release the resource, that is 1 and 2 they have taken, and then 2 and 1 they have released. So this is the use of releasing and acquiring the resources in your deadlock situations. So this can happen for deadlock free codes also and code with potential deadlock. So these two codes again can be used further using classes, that is A class, B class. First condition can be deadlock free code, that is the normal deadlock, without deadlock, how resources can be used for two resources. Further, they have continued it with the B type by using a code with potential deadlock. So this code can somewhere cause deadlock conditions also. Use both resources at a time when they have said that time there is a condition that deadlock can happen. So this is when two resources putting values together or access together by both the conditions, that is A as well as B, can cause a problem because two people, that is two main classes, are trying to access the same data or resource. So what is the definition of deadlock? A set of processes if deadlock. When I say when does my deadlock occur? So when my deadlock occurs, each process in the set waiting for an event. So my each and every process. So suppose I have four processes going on at a time, A, B, C, D. So A, B, C, D. From that, C, D, A, B, C are waiting and D is working. So when all the processes are waiting in a waiting state, and second, that event can be caused only by another process, because of whom they are waiting, because of D process they are waiting, and because of which there is a deadlock. So these are the conditions why deadlock occur. First is because it is waiting for some another process to complete, and the reason is they are waiting for that person to complete their task, and that is the reason the deadlock situation can occur. So what are the conditions of deadlock? There are four conditions that must hold a deadlock. Why? How can deadlock occur? So there are four conditions. First one is mutual exclusion. Second one is hold and wait. Third one is no preemption. And fourth one is circular wait condition. I forgot to tell you, preemptable means here preemptable and non-preemptable. So preemptable is which we can take back, non-preemptable is vice versa. That means if I take it back and if I have some problem because of it, can be said as non-preemptable resources. So here when we are talking about conditions for resource deadlock, we'll go one by one. First one is mutual exclusion. What does the word mutual exclusion means? We'll see that. Each resource is either currently assigned to exactly one process or is available. So when I'm talking about a deadlock condition, what will happen if my four processes are working, and from that what will happen, each resource will be working for one condition, that is one process, or it will be in the available state. Likewise, suppose I say mouse I am currently moving, I am using for one task to complete. If I am not moving it, that means it's available for access. That is first one, mutual exclusion condition. Either one resource is busy in something or it can wait for some condition to occur. Second one is hold and wait condition. Processes currently holding resources that were granted earlier can request new resource. So generally, when we talk about hold and wait conditions, process if it is holding a resource, then what you can do, if a new request comes for that resource, the second resource which has been requested has to wait till the first person releases it. If not, if it tries to access it, it will occur a deadlock. Third is no preemption condition. That is, resources previously granted cannot be forcibly taken away. So if my system has allocated me a resource, if somebody else is trying to forcibly take it, then there could be explicitly holding stage for a process who is actually running. So that time, this condition is called as no preemption condition. Circular wait condition is there must be circular list of two or more processes, each of which is waiting for a resource held by the next member of the chain. So circular wait condition means if in a circular motion I am arranging A, B, C and D, and when A is processing, D is been waiting for A to get the task completed. Somewhere for D, C is been waiting for some resources to complete, but D is again waiting for A. Likewise, A is waiting for B to get the task completed. so that it would release the resources which has been taken from A. So this is a circular chain which is going on among the processes, and that is called as a circular wait condition. So all four of these conditions must be present for a resource deadlock to occur. So all these four conditions should be there so that deadlock will occur. If any one of them, suppose if I say there is no hold and wait condition occurring, so there would never be a deadlock. See, I repeat it. All four of these conditions must be present for a resource deadlock to occur. If all the four conditions satisfy these four conditions, then only deadlock will occur. If any one of these condition is not there, is absent, then there will be never a deadlock which will occur in the system. So what are the deadlock models? So first one is a resource allocation graph holding a resource. See, here there is only a game of arrows, how you have to know. Requesting a resource and deadlock. So basically first one is holding a resource, means my R is holding a resource A because it is showing me a arrow towards A with upward direction only, but it's a circle here, that is A is a resource and my actual request is from R. Second is requesting a resource. My class B is requesting a resource to this particular S condition. So that is the second one. And this is circular wait condition which is going on as I explained it to you. So that is being called as deadlock condition. So a directed arc, that is a directed arc from a process to resource, from a process to resource, means that the process is currently blocked waiting for that resource. In figure 6.3b, that is this one, process B is waiting for resource S. It is requested and is waiting because that is the reason resource S is being in the box and process is in the circle condition. We see deadlock process C is waiting for resource, C is waiting for T, but D has not released some resources which T requires. That is the reason T is also waiting, C is also waiting, and because of which U is also waiting because they both have not completed their task held by C, and that is the reason both processes will wait forever. Until and unless D doesn't release, all these processes will wait for the resource to get completed. What will happen? A deadlock condition will occur, and they will be set as an example. When you define this circular condition, how do you define it? C dash, T dash, D dash, U dash, C. That means it will go on completing their cycle, and that circular graph will never get, that is unending. So that is the reason it is given as a circular wait condition, and which is in turn called as deadlock, or which in turn returns in deadlock. So this is one condition. With this I will stop here for this lecture. We'll continue the next topic in the next lecture. Thank you.